let's go for it. Okay, so our next session, for our next session, we have Karel Simon from Red Hat, who will be talking about templates, a mechanism to build great VMs. So you can build VMs or you can build great VMs. Let's see what is this about. Thank you, Karel, and all yours.
Okay, thank you. So today I would like to talk about common templates and how to build VMs with them. At first, let's go over topics which you can find in this presentation. Firstly, we will talk about what common templates are and the key factors which defines templates. Then we will talk about which operating system are supported. And after that, we'll have a brief introduction how common templates are working. And at the end, I will show you how you can use them. So at first, what are common templates? Common templates were created to handle common usage scenarios of VMs. The idea is to reuse and enhance the concept of OpenShift templates and its parameter expansions, and also to reuse the keyword VM spec structure. There is one limitation that common templates are only working on OpenShift. That's because Kubernetes currently doesn't have support for templates, but we are looking for solutions how to enable them on Kubernetes as well. And now to key factors. There are three key factors. One of them is operating system. This allows to ensure that emulated hardware is compatible with guest OS. Then there is workload. I will talk about that later. And size. These sizes vary the required memory and the number of CPU cores. Here you can see part of the large RHEL 8 server template. You can see that the template consists of information about operating system, like name, supported versions. This information is used only for or via web console, OpenShift web console. And at the bottom, you can see a part of the definition of virtual machine. The VM definition is missing here, but it will be shown on a later slide. Common templates have few requirements. Before you start working with templates, you have to install few other projects into your cluster. At first, you will need keyword, of course. Then you will need CDI. CDI is a persistent storage management add-on for Kubernetes. Template validator, it's a keyword add-on to check the annotations on templates and to reject them if invalid. And virtctl. Virtctl is required only when you are working with templates via command line. If you are using web console, you don't need it. And now let's go to section how to install common templates. There are two ways how to install common templates. First way is via web console. Just look for an OpenShift virtualization operator in Operator Hub tab. You will select, for example, the latest version, just click on install, and the common templates will be installed for you. The second way how to install common templates is via hyperconverged cluster operator. Just run the commands which are in this presentation, and common templates will be installed as well. Both ways of these installations will install all components required to run common templates into your cluster. And now let's jump to supported operating system. Currently, we support RHEL, CentOS, Fedora, Windows 10, Windows Server, Ubuntu and OpenSUSE operating system, and of course, PRs which add support for new operating systems are welcome. And now, how common templates work. Templates are generated from meta templates via Ansible. To load all necessary information about the operating system, we are using libos info, which contains info about, for example, minimal memory requirements. And as I said in previous slide, each template has a desktop, server, and some of the operating system have high performance workload. The difference between these workloads are the desktop workload has a tablet device, which other workloads doesn't have. Desktop or server should be used when you would like to have maximum flexibility. And high performance workload, you can use it when you would like to have, for example, better performance because it has IO threads feature enabled by default. Templates have some useful features like validation rules, and I will talk about them in the upcoming slide. Then you can, in template, you can set, for example, the CPU topology, like number of socket, cores, and thread, network devices, and storages. Before you use the template, you have to create a data volume, which will contain image with operating system you want to run. Example of the data volume is in the slide. After the data volume is created, you can create a VM from a template. And after that, CDI will start cloning the original data volume. And after the cloning is completed, VM can start using the clone of the original data volume. As I said before, template has some good, nice features like validations. On this slide, you can see an example of validation rule. I have to mention that if you would like to use validation, you need KubeVirt template validator installed in your cluster. Otherwise, it will not work. And if you can see, this rule is checking the minimal requested memory. It's checking if it has value higher than 1.5 giga. If it doesn't have, or if the requirement is lower, this VM will not be created. The template validator will deny that. You can, of course, create your own rule, which will then, for example, check number of CPU cores, or, for example, if the disk volume is using SATA or Twirt IO. On this slide, you can find part of the VM definition from the template. As I said before, you can set CPU topology, like number of socket, cores, threads. You can set the requested memory. You can set input devices, for example, tablet in this case, network devices, or volumes. And now, how to use common templates. There are two options how to run VM from templates. First one is via OpenShift Web Console. In this case, you can just go to Workloads tab, click on Virtualization, and then go through the VM creation wizard. As you can see in the picture, you can select from many operating system. Web Console will then create a VM which is based on the selected template. And second way how to create a VM is via command line. To create a VM via command line, you have to just run the OC process command, then the name of the template. Then you have to specify the name and the namespace of the original data volume, and then just run OC apply. This will create the VM. Then you have to start the VM by virtctl start and the name of the VM. And then after it's booted, you just run the CTL console and the name of the VM, and you can work with this VM as with any other VM. And that's all from me. Thank you for attending. And if you have any question or comment.
Hey there, we actually did have a question in Slack chat, which is Sachin. I don't know how to pronounce your name, sorry. Wants to know if the OpenShift virtualization operator can be installed in vanilla Kubernetes, or should he be using the hyper-converged operator?
You can use both. Issue is that on Kubernetes or on vanilla Kubernetes, the templates will not work. So this feature will not be there.
Okay. Will the templates work on? This is from. Will the templates work on OKD?
Yeah, they are meant primarily for the OpenShift/OKD. But in the future, we are working on adding support for Kubernetes as well.